Alright, you guys, if you guys could please turn to Unit 6, Similar Figures. Alright, if A and B are two numbers or quantities and B does not equal 0, then the ratio of A to B can be written like this or like this. Okay? Ratios are usually expressed in simplest form. Two ratios that have the same simplified form are called equivalent ratios. For example, if I gave you the fraction 7 over 14, you could simplify that to 1 over 2. So 7 over 14 and 1 over 2, or 7 to 14 and 1 to 2 would be equivalent ratios. Okay? An equation that states that two ratios are equal is called a proportion. So for example, this one, of course, once again, B and D cannot equal 0. The numbers B and C are the means of the proportion, as labeled here. The numbers A and D are the extremes of the proportion. Okay? The geometric mean of two positive numbers, A and B, is the positive number x that satisfies this equation. So if I ask you to find the geometric mean of a certain ratio, this is the equation you're going to use. Okay? Alright, a couple different properties. The cross products property, in a proportion, the product of the extremes equals the product of the mean. So basically, if you have a fraction equal to another fraction, you can cross multiply. Also, if two ratios are equal, the reciprocal property states that their reciprocals are also equal. So if I have A over B equals C over D, I can just flip both those fractions over, and I get another true proportion. Also, if you interchange the means of a proportion, then you form another true proportion. So in this case, if you go across like this, A over C equals B over D, this is another true proportion. And then finally, in a proportion, if you add the value of each ratio's denominator to its numerator, then you form another true proportion. So A plus B over B equals C plus D over D. Alright. If two polygons are similar, then the ratio of the lengths of two corresponding sides is called the scale factor. Okay? Similar, what similar means, I have it down here. Two polygons are similar if the corresponding angles are congruent and the corresponding sides are proportional. Okay? So for example, in this diagram here, let me write this down. Choose a different color. In this diagram here, quadrilateral ABCD is similar, this little symbol means similar, to quadrilateral EFGH. And the way that we know that is because the corresponding angles are congruent and the ratios of the corresponding sides are all the same. Okay? In this case, let's imagine that this side was length, I don't know, 10, and this side was length 5. Okay? Then the scale factor would be 10 to 5, which simplifies to 2 to 1. Okay? Alright. On the right over here, I have some postulates or theorems that you can use to prove that two triangles are similar. The AA similarity postulate, remember this little symbol means similar. If two angles in one triangle are congruent to two angles in another triangle, then the two triangles are similar. Okay? Also, let me scroll down a bit. If an angle in one triangle is congruent to an angle in a second triangle, and the lengths of the sides including these angles, remember including means the angle is in between those sides, if the lengths of the sides including the angle are proportional, okay, then the triangles are similar. And lastly, if all the corresponding side lengths of two triangles are proportional, then the triangles are similar. Okay? These are very they're a lot like the congruent postulates or theorems, congruent postulates and theorems. Make sure you don't get them confused. Remember, the SSS and SAS and the things that we learned before, those postulates and theorems prove that two triangles are congruent. Congruent means they're exactly the same. These two triangles obviously are not exactly the same. One is bigger than the other. Okay, so these postulates and theorems only prove that they're similar. In other words, proportional, okay? The triangle proportionality theorem states that if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So for example, if TU and QR are parallel, then RT over TQ equals RU over US. Okay? And conversely, if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So if this is this over this equals this over this, then these two lines have to be parallel. Okay, let's go down a bit. Oop. Sorry about that. Give me a sec. Okay, if three lines intersect two transversals, then they divide the transversals proportionally. So for example, here I have three parallel lines and two transversals, L and M. Oh, I see what I did here. Hold on. This is supposed to be a W. Sorry about that. Give me a sec. There we go. Okay. So in this case, UW over WY equals VX over XZ. Also, if a ray bisects an angle of a triangle, then it divides the opposite sides into segments whose lengths are proportional to the lengths of the other two sides. So here I have a ray bisecting this angle. It's cutting this angle in half. So AD over DB equals CA over CB. Alright, last bit of a note. A dilation is a transformation that stretches or shrinks a figure to create a similar figure. This is kind of a crude drawing, but what I did here is I tried to make this a bigger version of this. So triangles ABC and XYZ are similar. XYZ is supposed to be a little bigger, even though I'm not sure what it looks like. A dilation is a type of similarity transformation, and the scale factor of a dilation is the ratio of a side length of the image to the corresponding side length of the original figure. Okay. Coordinate notation for a dilation, you can describe. Where's my cursor? There it is. You can describe a dilation with respect to the origin with the notation xy, kx, ky. Okay, where k is the scale factor of the dilation. If k is in between 0 and 1, you're going to get a reduction. Basically, the image is going to be smaller than the original figure. If k is bigger than 1, you're going to get an enlargement, like over here, where the image is bigger than the original figure. Alright, and that's all for Unit 6.